Hi guys, in this video here we will use the same data as before to model the mean monthly maximum temperature for Cape Town. So we will create a sine model for this data here. Now remember that we did it by hand, and the model that we used was t equals a sine b t take c plus d. And I hope you still remember what A, B, and C, and D did. Now on your calculator you can do a thing called regression, and with regression what you find is A, B, C, and D. Just much easier than doing it by hand, and also a lot more accurate. So here goes. You open the calculator, and we're going to menu 2, the statistics menu. So you can press menu and then 2 and you're there. Now we need to put that data in. Remember that the months were 1 to 12 and we're going to put them in list 1. So the independent variable goes in list 1. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not quite, 12. There you go. Check. Yes. In list 2 we put our independent variable, so that's the temperature. 28, 27, 25 and a half, 22, 18 and a half, 16, 15, 16, 18, 21 and a half, 24, 26. Now what I'll do is press calc for calculations. And then what I want to press is regression. But before I press regression, I'm going to look at the set here, because I want to tell the calculator where my data is, or at least I need to check that my calculator knows where the data is. Now, my data is a 2-variable data, because I've got month and temperature, and I'm going to compare them against each other. That makes it 2 variables. The independent variable is the X list. It's in list 1, it says here. So that's great, that's good. Don't have to do anything. The dependent variable is the Y list, and it's in list 2. So that's great again. If you find that these things are wrong, then you just press list and you select the list where your data is. So remember to look at these 2 lines here for this particular problem. If everything is okay, you press exit, you go back. Then you press regression, and then you have a choice of options: linear regression, quadratic, cubic, quartic, etc. And one of them is the sine regression, which I want here. So I press the sine regression, and there it comes up with the answer. Now that answer, I can do a screenshot of that answer, and I'll paste it in. So here we go. I'm going to paste it in my work for us to look at. And as you can see, it has given me the values for A, B, C, and D. So that's great. I've got my function. The function I'm after is t equals 6.29 sine of 0.524 t, and then what I have here was negative take 0.967 plus 21.4. Now you may already see the discrepancy with what we had before. It's not quite the same. Let's go through it and let's pick up what's wrong and what's right. So the 6.29, I believe it used to be 6.5. That's what we found in our previous problem. Yeah, so that's quite close. It's just that the calculator is better at doing it. D, we had 21.5. It has 21.4. Pretty good. 0.524 here for B. That is pretty much exactly pi on 6. Type it in on your calculator and you'll find that. The big discrepancy is this one here. we had a 10 here, and now it says 0.9617. How is that difference coming about? Well, we have to look closely at our calculator. You know, we used a negative symbol there, because that's how we do regression by hand, with the negative symbol. But for some reason, this calculator here uses a plus symbol. So that means this negative here should be a plus. So instead of negative 10 in our by hand, t take 10, it's going to be t plus almost 1. Now that's still a bit of a discrepancy, but what happened is that from the principal axis we found this point here to be the first point where the sine function started, and it was at 10, right? Approximately 10, because I just couldn't more accurately see it from this graph. The calculator has found this point, but not here. It has found this point here. So on the left hand side of the graph, at approximately -1. Now you would expect it to be like -2 and 10, because 2 and 10 add up to 12, which is our period, or maybe -1 and 11. But maybe the rounding that we did, because we're not accurate, well, messed it up a little bit. So this -1 here is the accurate answer. So -1 take -1 would be a plus approximately 1, which is what we have here. So this is correct. This 0.967 with a plus is correct. It's just not the same point that we used. But you know, that's how it works with periodic functions. They start here, they start here, they start here again. So you've got options. So there we go. This is the formula, the function that models the data using regression on your calculator.